So let's recap everything. That's why we look at absolute value. We look at now we not only look at absolute value, we're looking at absolute value of the series. But we not only that, we look for the next term. So think about it. If your next term is 1 and the prior term is 5, so 1 over 5. And if it goes to keep on going to the infinite, if it's less than 1, then you can see that it's going to convergent. Does that make sense? If your next term is smaller. Because only if it's greater than, if your next term is greater than that, then actually it doesn't make sense. So greater than 1 is going to be divergent. Are we okay? So we're going to go in to look at, what can we do to make sure it works. So we're going to give an example here. And this example is going to be summation of n equal to 1 of infinite at -1 to the n minus 1 to the n squared plus 1 all over 2 to the n.
Is it -1 to the n minus 1 times n squared?
Yeah.
Or is it times n squared plus
1? N squared plus 1. Let me put a parenthesis there.
Yeah, it's a pretty difficult starting example.
The work is actually super easy. That you just have to look at this and you have to understand the algebraic perspective.
Oh, so it's the most difficult.
No, it's not. It's an algebra you can handle. It's not like something like so wild and so crazy. Remember last time, if I have alternative, I can take that -1 away. And that's going to use it here too. And then just understand the n plus 1 situation. If anything, you can simplify. The only thing you need to know is be able to divide fraction and understand how exponential rule works. Then you'll be okay. You'll be okay. Okay, so we're going to talk about that. So what we're going to do is we're going to plug in the a to the n plus 1. So it'll be going to be -1 to the n plus 1 minus 1 is going to be what? No, it'll be n. Because if you have n plus 1, remember the top term need to be n plus 1, right? So I'm going to plug in n plus 1 for n. So it's going to be n plus 1 minus 1. And that's going to be n. So here it's going to be n plus 1 to the square plus 1. Does that make sense?
Yeah.
All over 2 to the n plus 1. And then we're going to write the bigger fractions on the bottom. We're going to do a n plus 1. Yeah, we're going to do the a to the n now. We only did the a to the n plus 1. I only plug in n plus 1 on this. All over -1 to the n minus 1 over n squared plus 1 over 2 to the n. And we're going to say absolute value of this. It's pretty massive.
I feel like it'd be easier to just plug in.
Any questions so far? Any questions?
You literally just like plug it in on the top and bottom.
Yep.
Okay.
And what does the absolute value do? Make it positive. So which part is going to go away? All this part, right? Does that make sense? It make it all the negative term just kind of puff, disappear. So then can I just do this? So it'll be equal to m. Sorry, I'm gonna write down summation of n equal to 1 summation of that -1 goes away, and then I'm gonna have a n plus 1 square plus 1 over 2 to the n plus 1. Now I'm gonna do keep change flip. So it's gonna be 2 to the n over n squared plus 1. Am I going too fast? Is okay? Okay. Now, what happened is, if you know your exponential rule, can I erase this to the 2n plus 1? Can I change this to what? 2 to the n times 2. Does that make sense? All those like algebra 1 stuff coming back. And if you have 2n to the 2, so then that's going to be summation of n equal to 1 summation. This one 2 to the n times 2. I'm just going to rewrite it so that way you can see it. Of n squared plus 1. And then this one is going to be, that's expand them. So it'll be n squared plus 2n plus 1 plus 2. And then plus 1, right? N squared plus 2n plus 2.
That's true.
Mm-hmm.
Why do you split it up?
I split up because I can cancel them.
No, above n plus 1 squared. N plus 1 whole squared.
That one is never. Wait, which one?
From n plus 1 squared. There was n plus 1.
But it can't be.
Do you understand how I cancel?
Yeah, she doesn't understand what's the point of expanding if you cannot cancel it out.
Oh, not well, because later on we can limit approach infinity. Are we okay here? So now we're gonna end up to be n squared plus 2n plus 2 over 2 times n squared plus 2. Does that make sense? And remember, we had to do limit as n approach infinity. So limit as n approach infinity. I'm sorry, I don't need to write this. My bad. I kind of get a habit of writing that. Okay, so limit approach infinity. What will happen? You divide it by top and bottom by what? N squared. Bobby, pay attention.
That was not me.
Oh, okay.
We were discussing the
Yeah, we were discussing why don't we just plug in from the start? It was not we, it was these two.
Oh, okay.
Yeah, why
don't we just not plug in the start?
Okay, so shh, let me finish. So now we're gonna do n squared over n. So this one is gonna become eventually equal to what? 1 plus 2 over n plus 2 over n squared over 2 plus 2 over n squared, and you know that's equal to 1 over 2. And since it's 1 over 2, then it's what? Convergent. Does that make sense?
I thought this was gonna be fun. Why didn't we just do all that?
It's absolute convergent. Not only anything, this is called absolute convergent.
Also, if you plugged in from the beginning, there'd be no.
Is there a way to like determine that we're gonna do this versus any other test, or is it just whatever's most feasible?
Okay, so very good question. Very good question. Gabby is asking a good question. The reason is how do we know when do we use a ratio test? I'm gonna give you a good example. When we know that we use exponential test, not ratio test, is because you have some type of to the n power. Because usually, if you have something to the, so for example, 3 to the n, right? And then if you have 3 to the n plus 1 versus 3 to the n, 3 to the n will cancel out, left with the 3. So it makes that goes away. Second possibility is also something that you can cancel before. What do we learn that something we can cancel before? So two things you need to know is some type of function to the n power like this, or some type of number factorial, because factorial can also cancel out. Do you remember? That's like if you have n plus 1 factorial over n factorial, that will cancel out because this one's going to be n plus 1 times n factorial over n factorial. Do you remember that?
Yep.
That can mathematically cancel out. Does that make sense?
Wait, I'm sorry. So the
So there was two places use ratio test. Anything to the n power?
N plus 1 factorial to the n plus 1 times n factorial.
Yeah.
How do you
But
do
I
that?
think it's a lot of this.
I just write down the next term. So n factorial is, let's say 5 factorial is 5 times 4 times 3 times 2 times 1. So can I just write down 5 times 4 factorial? So if I have, let's say 5 factorial over 4 factorial like this, can I say write down 5 times 4 factorial over 4 factorial, and this can cancel out? This is one of the things that you can simplify in terms of factorial. So you can apply that to here as well. Okay, so we're gonna give you questions here, and we're gonna let you try it, and make sure you're working out, because this is the first time that we're gonna do something kind of important. So we're gonna do also factorial. So we're gonna put both of them in combinations. So we're gonna give you this question: summation of n equal to 0 of infinity of 2 to the n over n factorial. This is very, very common one. Remember, later we're gonna do something like the question counter asked way earlier. I don't know if he remember, but I remember things that he asked, probably more than he does. So we're gonna answer your question of n equal to 1 to infinite of n to the n power over n factorial. Okay, we're gonna answer that one.
Okay. Oh wait, no, I think I know the answer to that one.
What do you think the answer to that one?
It has to be approaching infinity. N to the n's bigger.
N to the n over n factorial? No.
That's not approaching infinity.
Well, it's not the end up result is gonna be, well, it's divergent.
Right. Yeah.
But if you do the ratio test, it doesn't equal to a value. So it equal to a very cool value. So that's what I'm gonna get to.
So you want us to do this one as a
Yeah.
groups?
Yep.
What is just a bit?
He can't put Connor.
The designing conditions for this, is there anything you have to, you just go straight to the test, right?
Yeah, just go straight to test. The reason why I will choose ratio test over other tests is because it has two criteria that Gabby is asking. Right? So the last example I give it to you, it has something to the 2 to the n. So this is the hint ratio test.
And is that anywhere in the fractions?
Is that anywhere in a fraction? Yes. So it's 2 to the n. Or something like n factorial. That's going to give you a proof. But this one happened to be both. This one happened to be both.
No, you don't do the peak flip when you divide correct.
Yeah, that's that.
Oh, I thought I.
It's literally mint, keep, change.
No, like I got here. I'm from Honolulu.
KCF. Key change flip.
What's wrong with it? I saw the problem. I did. Do you know how to? I did.
You're so whiny.
Yeah, you're the whiny one.
I know about
Connor, get to work.
I got it. I got it.
You sure? What do you?
0 is good. It's a convergent.
Okay.
So even look at it. We talked about before, right? Which one goes faster, right? It turns out n factorial is a faster than the thing. So if it's n to the n factorial, n to the n power is actually faster than n factorial. So remember that one thing that I give it to you was the highest one. It was n to the n power, and the next thing was n factorial, and next thing it was like anything to the n power. So like a number over n. So we're gonna give you that whole page, and then you can have it later. So I'm gonna send it to you today when you're doing your homework. All the information about series, just like a concise version of everything. Okay, so it has two criteria here. It has n factorial and has 2 to the n. Great, we can use the things that we always use. So then we say, okay, well, we compare limits as n approach to infinity of 2 to the n plus 1 over n plus 1 factorial over 2 to the n over n factorial. And we're going to do absolute value of this, although this one doesn't really do anything because it never have alternated. It's not alternating. I don't have to worry about whether absolute value or not. So then there's going to be limits as n approach infinity of 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Keep, change, flip. Keep, change, and flip. Because you change the dividing sign to multiplication and flip that one. So equal to the limit as n approach infinity of 2 to the n times 2 over n plus 1 times n factorial, because you want a factorial to get rid of each other. So that's n factorial over 2 to the n. Does that make sense?
Yeah.
So this thing's going to cancel out nice evenly, and this is going to cancel out nicely. So you got limit as n approach infinity of 2 over n plus 1 equal to 0. And it's less than 1, so it's convergent. Absolute convergent. I'm going to give you the next question. So what is summation of n equal to 0 of infinity of n squared times 2 to the n plus 1 over 3 to the n?
Oh, this one?
Mm-hmm.
Yeah. Power table over here. Yeah, it's probably so. See who laughs.
So if I check you, I'm gonna check the result, whether the sum, the n approaching infinity is the right number. You cannot just be the answer might be like say 1/4, and you get 2/3. Then there's some math that's wrong. So I need to check that part of math. Mhm.
Four to the n, you do like 3. Okay, let's see.
You're pretty much just practicing exponential rule, factorial rules, and then keep change flip, and then limit x approach infinity. Mm-hmm. Mm-hmm. No, other people haven't finished it. Liam, you got it? Eva got it? Nicole? Matthias? Margot? The idea you want to cancel out those 2 to the n's and 3 to the n's. That's the idea. So you want to split up those using proper exponential rules. Like people don't understand like how important exponential rule. It's like I teach course outside. I start kids at 4th grade and I taught them exponential rules. And because that's the first time they learn about exponents. But I will teach them like all the exponential rule. I just say you're gonna have to use it, and I give them tests, keep on giving tests until they understand it completely. And because you use it all the time. Connor, you guys got it?
You do.
Yes, I did.
You fully simplified it.
Yeah, I did. Oh, you made it phenomenal. Yes, I made it up.
Numerator plus denominator should end up to be 5.
Yeah.
Yeah.
Okay. Do I need to go over it?
Dude, you can't.
Can I do it on?
N plus 1 square, right? Times 2 to the n plus 1, so be n plus 2. Over 3 to the n plus 1 times what? Well, keep change flip. So n squared. Well, I'm gonna just move it to the other side, so that makes it faster. So I'm lazy.
Yep.
So it's gonna be 3 to the n over n squared times 2 to the n plus 1. So this can cancel out with this. Left with the what? It should be 2 on the top, right? Does that make sense? And this can cancel out. This left with 3 at here. So that's equal to 2 to the n plus 1 square all over 3 to the n square. Now, if n approach infinity, this one's automatically 2/3. And 2/3 is less than 1, then it's convergent. Is that okay?
No, but I did that.
How do you do without expanding? Like, how do you know that?
I expand it in my head. It'll be, but because all the term is only leading coefficient counts, so only the leading term really counts. So I kind of just did it in my head. But it would be 2n squared plus 4n plus 2. And it didn't matter what happened term. That's called n behavior. Only the first term matter for the n behavior. So you don't worry about the rest of the term because they go to infinite. So this one's kind of hard. This one is gonna be the summation, and we're gonna talk about. And the thing is about intuition, and this part, intuition is correct that he says is gonna be divergent because he says it's gonna go to infinite. But we also told you that n to the n going faster than n to the factorial. But then we have to really establish a proof when we want to talk to other people. We have to say, well, this is a proof. Now, sometimes you can equal to 1, right? Equal to 1 just inconclusive. Like you just have to do a different test to check whether it's true, whether it's integral test or other tests that you can do. I personally like ratio tests just because they're not very hard. It's just a lot of writing, but you can concise a writing to 2 lines, and that's pretty much that's it. Just do keep changing inside your head and just kind of cancel out as many things as possible, and you're pretty much going on further. Now, for this one particular one is actually pretty interesting. If you have, I'm gonna do it with you. So this one's gonna be n, which is limits of n approach infinity of absolute value of n plus 1 to the n plus 1 over n plus 1 factorial all over n to the n over n like this. And again, if I do it so often, I probably don't need to write that anymore. So, but you gotta be careful how you expanding this. So we got m plus 1 to the n plus 1 over m plus 1 factorial times n to the factorial over n to the n. So can I just focus on the n factorial part? So that's going to be n. How do I change n plus 1 factorial to n factorial? N plus 1 times n factorial times n to the n over n factorial over n plus 1 to the n plus 1. So this one's going to cancel out like this. You can cancel out n plus 1, so you're left with what?
Oh, that's not what I did.
N plus 1 times n plus 1. Wait, did I?
No,
Yeah.
I didn't.
N plus 1, right?
Wait, you move it too fast.
So this cancel out. N plus 1 to the n to the n. Limit as n approach infinity. No, there is an L-Hopter rule. Talk about this. So it was a limit as n approach infinity. Now I'm gonna split this, so it'll be 1 plus 1 over n to the n. And then you're gonna do L-Hopter rule after that. Do you guys remember?
No, dude, I lost it a while ago.
Uh, yeah.
I can't calculus. I just don't get algebra.
Okay. Do you understand that's n plus 1 to the n plus 1 here? Do you understand the n factorial cancel out?
That. Yeah, that's and then the next
Okay.
one.
So can I rewrite this to n plus 1 to the n power times n plus 1? Because
Oh,
this is the
yeah,
one.
The first power.
Yes.
Oh, that's so bad. Okay, you got me back. I'm back on track.
Sorry for you, Mr.
I,
You have to deal with him.
sometimes I wonder, how did you get a 5 on these? Sometimes.
Because, no, because the APCM really didn't have that much count or that much algebra.
That's true. That has to be true.
I mean, I passed, I did not take a derivative or an integral. And I passed.
Shut up, Bobby.
I didn't pay attention all year.
Okay.
Wait, can you go back? I'm still being done.
It was a pretty easy exam.
But now you sound like an asshole though.
Like, no, the most I knew how to do, I started paying attention, like, maybe the 4 or 5 weeks. So I kind of knew how to take the integrals on, like, the spinning things.
Oh, the rotations.
Yeah.
Oh, ew, gross.
That was about all.
I don't think that question's on the test though. The rotation volumes are not on the test. Not last year.
It's never too.
It was.
That's never.
Oh, the one with the C. That everybody trying to find the C and nobody can find the C.
Oh, wait, I can't say that. That's
All right. So I'm not gonna go through this, but I went through this one on El Hopto rule, which is this one is a 1 to the infinity power. So it's indeterminate form. But this is also the things that I would tell people to memorize. This will actually work out to be E.
Wide slides?
Yep.
It's a definition of
I
E,
don't like that.
and the E is greater than 1. Therefore, it's diverge.
You screwed with us here,
I
right?
don't like this. I don't like
Is that,
this.
that's an accepting thing.
How?
No, there's just one of the definition.
Interesting.
We just proved E.
There's a proof to it.
There is a proof to it. You want me to show you the proof?
No.
We're good.
Yeah,
We did that with the notes before. It's on your notes, so that's why I didn't want to.
Take your word for it.
We've done it before. Oh, it does.
We've done it before when we do it in. We've done it before. Okay, so the next question I'm gonna give it to you is something that is very similar. We're gonna give you a questions.
Kind of threw a curveball at us.
No, it's not. This ratio test is just very, very standard. It's not. It's not like something that is a curveball.
Yeah. Because it's the definition.
So you don't understand it, you're just accepting it.
Yeah.
Yeah, that's different.
Now there are root tests that you're gonna be using, but so sometimes you will get an inconclusive case. So if you get inconclusive case, then you might have to do other things. So you say, well, there's nothing I can do, so you can do other things. So this is an inconclusive case. So we're gonna give you some example of each one because we give you example of failed test. We give you an example that's diverge, but we didn't give you a test that's fail. So we're gonna give you this one: summation of n equal to 1, a factorial of -1 to the nth power times square root n over square root n n plus 1.
The question we're doing?
Yeah.
Ooh. With the ratio test? Ooh.
So I forgot which person asked me. Was it Gabby or somebody? Asked me, what if the ratio test fail? Did somebody ask me that? That was Nicole? Yeah. So we're gonna talk about this case. This case is a fail case. But you had to prove it's fail first. What is a fail? No, equal to 1. If it's greater than 1, it's gonna be automatic diverge. So it's not really a failed test. But if it's equal to 1, then it's a failed test.
Oh, no. I thought you said, yeah, so I didn't get it. Yeah. Well, it has to be- Yeah.
How much time we have? Okay, we're just gonna go jump into it. So at here, we're gonna take absolute value of it. So does a -1 to the n matter? So it'd be square root of n plus 1 over m plus 2. Does that make sense? Times by m plus 1 over square root n. Does that make sense so far? So then it's going to be
Cancel out and plus one.
Can I put this in the one simple square root? Over m plus 1. I'm going to change it to a square root so that's easier to organize. I switch this places. Oh, this is a plus 2, so wait, this is a plus 2, right? So I'm just switch this places, switch over. Now I can multiply it together, but if I limit limit n approach infinity, in this particular case, it's going to be 1. This is going to be 1 also, right? So that's equal to 1. So you says, since it's inconclusive, so if it's inconclusive, then what do? What you're going to do is you're going to do, says, well, this is alternative series, so can I do alternative series tests?
Yeah.
So yeah, so I can do alternative series tests. So alternative series test is this alternative? Well, -1 to the n. So is limit as n approach infinity of square root n over n plus 1, what does that equal to? 0. Good, because the top part is not as fast as the bottom part, right? And then what do? What do? Then you can do it two-way. You can do by checking the L'Hopital rule. And if you do L'Hopital rule, it's also equal to 0. But I would have to check if a to the n plus 1 is less than a to the n. There's two ways to do that, but it's really hard to tell if square root n plus 1 over n plus 2 is less than square root n over n plus 1. So what you can do is you can take a derivative of this. We didn't talk about this. We're going to change the function to f of x equal to square root x over x plus 1. What happens if you take a derivative? Low 1/2 x to the negative 1/2 plus what? Minus what? X to the 1/2 times 1, right? Over x plus 1 square. Can I factor out the x to the negative 1/2? So what am I gonna get? So I might get 1/2 of x plus 1/2 and minus x, right?
Wouldn't be x, wouldn't be 1/2 x here with 2? Or...
Okay, hold on, let me finish. This will eventually simplify to negative x plus 1 over 2 square root x times x plus 1 squared. Now, if you figure out if x is greater than 1, what will happen? Well, if x greater than 1, this one doesn't matter, this one doesn't matter, this is all positive. It doesn't matter if sign changes. Now, if x is greater than 1, then you automatically says this always decreasing, always negative. If it's always negative, then it's actually a converge, because this is a converge situation due to AST. Bye, have a good day.
Student, 1 minute remaining until class.
Yeah, then. You need it? Oh, shoot. I don't know if I have it. Hold on a second, let me check.我没有哎、我看我的 wallet 没有，我的 wallet 也没有 Devon 的，我应该不是。但是我很少带 Max 去看医生啊。那他现在要吗？
我等一下带他去看牙是肯定要，他要就要等 insurance company，但肯定要够，我找找吧，可能不知道在哪个时间。
next time。
查着的好像，因为有一次他生病，你带他去看，然后我就没，然后我就没有
他生病什么时候？他没有生病啊，他很少生病。
pediatrician appointment，然后我再找找啊，你如果找到跟我讲。
Okay, well, I'll look for it. We'll see.
run down here because I think it's really important to get this in this one more time. Do you have them all written down? Yes. Okay, so let's go through it. First thing we check for every time is always the divergence test. So on number one, problem number one. The limit's going to equal 2/3. Not even 0 diverges. It's that fast. Don't worry about looking at the telescope and anything else. It's going to be divergent. Does that make sense to you? Next one. You know you can separate series by addition or subtraction? In this case, you have something that is, well, that's a geometric. This is geometric with 2 1/3 to the n. Do you see it? This, even partial fractions, that's going to be telescoping. So you get geometric and you have telescoping. Both of them would have to converge in order for this series to converge. You with me? Okay. So this is geometric and telescoping. Next one. Well, we go, okay, geometric, no, telescoping, no, but this can look like a P-series. Make them into a type of series if you can. Divergence test, cool. Geometric, no problem, you can make it geometric. Telescopic, partial fractions for telescoping. Here we have one, okay, this is a P-series, where P is greater than 1. That thing's going to converge, it can be that fast. Next one. For something like this, well, it's really easy to see that this is always positive. It's always continuous for n greater than 3, as it says right here. It's always decreasing. We only have a numerator besides 1. And the integral would be really easy because if you use a substitution of u equals ln of n gives you 1/n. It's right there. This is going to be u to the negative 1/2, and then we do an integral of that. So integral is nothing this. Next up, that, well, here's the difference between these two, what you should do and when you should do them. A lot of times when you have single, you see what I'm saying about single terms? There's not multiple terms here. When you have single terms, do a comparison test. This will be less than square root of n over n squared. Do a comparison test with that. This would be n to the 3/2. This is a P series. P is greater than 1. It's going to converge. Therefore, because it's always less than that by the comparison test, this series also converges. Does that make sense to you? So comparison test. Here, when you have more than one term, it's really hard to do this because you don't know what's less than. You don't know what's greater than because you have these other terms being added on or subtracted. It's really hard. Does that make sense? So with single terms, maybe try just a comparison test is way easier. Okay. With multiple terms, you're going to look at what it looks like, how it behaves. How it behaves is with the leading term. So we base it on this one, then we take a limit, A sub n over B sub n, and we do the limit comparison test. We okay with that one? Are you guys sure? I'm going to go too fast for you. Okay. Next one. This is just straight up, automatically, what? Alternate series. Just do alternate series. It's really easy to see that it is decreasing. It's really easy to see that the limit is going to be 0. Alternating series test. With this one, you actually have an option. You can do either the root test or the ratio test with this. It doesn't matter. So pick either one of this. The root test is a little tricky because you have to make n be something to the n power. It's possible. It's just not easy to do. Well, it is not super hard to do. You can do this. N to the first is the same thing as n to the n over n, which is the same thing as n to the 1 over n to the n. It looks weird, but you can do that. And that way you have this. The last one. When you get down to something like this, please do not start doing weird things like a ratio test or a root test when you have a sign all in there already. Is that going to work out for you? It's not alternating. So when you have something with a sine or a cosine or something like this, do the absolute value first. Because as soon as you do the absolute value, so use absolute value, as soon as you do that, then you can say, well, the absolute value of sine is always less than or equal to 1. Does that make sense? And then you have this comparison test idea. So try absolute value, and then you'll be able to use one of the test. But then, use the no, use the comparison test. Did this help you at all, the summary? Depends if you feel okay with that. Okay, so this will hopefully give you an idea of what you can do. This is every test that we've done. There's a lot of tests, but now you have at least an outline. Did this actually make sense for you? All right.
With this final rose, I choose all of you. I choose all of you.
Sync inventory across channels, sell online and off, run your business from anywhere. Lightspeed, the only commerce platform you'll ever need.
Okay, that right there is something that's in sequence notation. We have something that's, do you guys see how this is in terms of n? It says, hey, here's the sequence in terms of n. It says, well, where's the n going to start for us? Why is it going to start at 1 automatically? If I'm not getting anything over here, this thing's going to start at 1. So here's how you find out the terms of our sequence. It's not hard. All it is you start wherever I tell you to start. If I don't tell you to start, where you start at 1. That would mean that our first term, a sub 1, would happen when I plug in 1 for our n. So for instance, we go, okay, well, what happens when n is 1? That would be our first term. What's going to happen when n is 2? What's going to happen when n is 3? Or n is 4? Or n is 5? By the way, is this ever going to end for us? So we're just going to list out the first 5 terms just to get a feel for it. So if I want when n is 1, what I'm going to get out of here, we're going to call this a sub 1. It's going to be my very first term. It's going to say the sequence of a, so that's the same. When I plug in 1, or basically the first term of our sequence. So you guys feel okay with the idea here. It's not hard to find out, but you got to plug in 1. So let's plug in 1.